When we think of drones, we usually picture them fresh out of the box, looking perfect. Well, today we're going way beyond that. We're heading to the proving grounds, a place where these unmanned aerial vehicles are pushed to their absolute, and I mean absolute, breaking point.
So that brings up a really important question. What does it actually take to get a drone field ready? It sounds simple, right? But the answer involves this grueling, intense gauntlet of trials. This is how you separate the toys from the serious professional tools. It's how a drone proves it has the grit to operate in the most demanding conditions you can possibly imagine.
Okay, so welcome to the proving ground. We're not talking about some simple quality control check under fluorescent lights. Oh no. This is all about throwing these machines into pure chaos, into extreme environments, and giving them tasks that are just flat out impossible for a human to do. And it all starts with mastering the absolute basics.
So, stage one is all about control. Think about it. Before you can even begin to test a drone's smarts or its toughness, you have to be 100% certain that it can fly with flawless, perfect precision. It's got to master the fundamentals.
And that mastery, it all starts with a really deep understanding of its own power. Engineers have to know exactly how the motors are going to respond to every single command. Every rotation, every tiny adjustment, it all has to be perfectly modeled and then validated. This isn't just about taking off. This is the bedrock for every single complex move that drone will ever make.
Now, to get this right, they don't just, hover the drone in a lab. They put it through these specific, almost acrobatic flight tests. We're talking maneuvers with names like the triangle loop and the shoelace loop. And these aren't just for show. They're designed to push the motors through a huge range of thrusts. All that real-world data gets collected and used to fine-tune the control models until they are absolutely perfect.
All right, so once the motor control is totally locked in, the focus gets bigger. Now it's time to figure out how the drone's actual physical body cuts through the air. By crunching all the data from those flights, engineers can validate the entire aerodynamic design, making sure the drone is as stable, efficient, and predictable as the laws of physics will allow.
So, the drone can fly perfectly. Check. But, can it think? Well, that brings us to the next phase of the gauntlet, testing its intelligence. This is the big leap from just a remote-controlled vehicle to a truly autonomous system. And the heart of this intelligence is something called the Autonomous Flight Coordination Control System, or AFCCS for short. Let's be real. You can just think of it as the brain. It's all the software and hardware that lets a drone, or even a whole swarm of them, operate completely on their own. So what key skills does this brain need to have? Well, two big ones stand out: collision avoidance and formation flight. In other words, can a single drone spot an obstacle and just get out of the way by itself? And can a group of drones fly together like a single coordinated team? I mean, this isn't sci-fi anymore. This is the tech that lets a swarm of drones map a disaster zone or search a huge forest without constantly crashing into each other. It's a game changer. Okay, so the drone can fly, it can think. Now we get to the final critical question. Can it survive? Welcome to the last and, honestly, the most brutal phase of the proving ground, where the challenges get seriously extreme. And the first test of survival completely redefines what a drone even is. I mean, forget just flying. The question becomes, can this machine operate seamlessly in two totally different worlds, in the air and in the water?
So the drone has to fly perfectly, then it has to intentionally enter the water, that's called ingress, then it has to move around on the surface, which they call sailing, but then comes the really hard part, egress. It has to break the surface tension of the water and launch itself right back into the sky. Pulling off this transmedium feat is just an incredible piece of engineering.
A drone that can swim? Pretty impressive. But the gauntlet is far from over. The next test is way more violent. The question is brutally simple. Can it survive an explosion?
Yeah, the source material here is chillingly scientific about it. It says testers are looking at damage from combined shockwave and fragment impacts. Let me translate that for you. They're testing if the drone can take the hit from the blast wave and the deadly shrapnel that comes flying out with it. This is the ultimate test of just how tough this thing is built.
So after all of that, after mastering precision flight, autonomous thinking, surviving water, and even explosions, there's only one thing left to do. It's time for the final exam. A real mission in a real hazardous environment where the stakes could not possibly be higher.
And that final exam was the Fukushima validation mission. A special survey system gets mounted on the drone, and then it's flown right near the disabled nuclear power plant. Its job? to conduct an airborne survey grabbing critical data from an environment that is way, way too dangerous for any person to enter. And after the flight, all that data gets checked and double-checked for accuracy. This isn't just a test anymore. This is a real-world job.
And just like that, the journey is complete. We've watched a drone go from mastering simple shoelace loops to prove its motors worked, all the way to flying a critical survey mission at the site of a nuclear disaster. The gauntlet has been run, and the drone has proven its worth.
So this leaves us with a really fascinating thought to chew on. We now have autonomous machines that can swim, think for themselves, survive explosions, and operate in radioactive zones. It really makes you wonder, what's next? What's the next impossible environment that they're being designed to conquer right now? Deep sea vents? The surface of Mars? The possibilities are just as extreme as the tests they've already passed.